short session. They're very nicely on time. Only 1 minute after the deadline. I won't do an introduction of the session because I think you will get that along with my talk. So the name of my talk is Risk Management for Nanomedical Products in Relation to Safe Innovation for Emerging and Regulatory Requirements. So that's quite a mouthful, but I hope it will come during the talk. As anyone who has come to this conference more than once knows that obviously the application of nanotechnologies in healthcare brings innovative breakthroughs. Many of the talks here are about medicinal products. They're more effective, they're less toxic if you use nanotechnologies. However, also medical devices can benefit a lot from the application of nanotechnologies. A few years ago, I dedicated an entire talk to this. In the first version of my talk for today, I also had a couple of those slides, but it really got too much, so I'm sorry. Anyway, there are by now hundreds of products on the market, and there's many more in the pipeline. So the next question to ask for any new technologies, are there also new risks related to those new opportunities? If you keep in mind that, do I have a, yes, that the structures that we make with nanotechnologies are in the same type of size as subcellular structures. So if they can enter the cells, they can interact with those structures. So at least you can say there are challenges for risk management and for assessment of the benefit risk. Along the last number of years, we have seen also that there are emerging regulatory requirements, be it also really as requirements or as regulatory guidance. My personal conviction is that innovators and regulators have to interact in order to get the optimal outcome for this purpose. There's another Horizon 2020 project. It's called NanoReg 2. They are developing concepts for nanomaterials in general, but I believe they're also quite applicable to medical products. If you look at the center part, they have developed a safe innovation approach. And people who have heard me talk before might have seen this term before. But I'll briefly just explain. The safe innovation approach is actually a combination of two principles. The first is safe by design, where you already at the first stages of the innovation process try to integrate safety aspects. So this is at a stage where you can relatively easy still make changes in your design. And the aim is to reduce any potential health and environmental risks and uncertainties by the time that you get to a final product. The other aspect is regulatory preparedness. Regulators need to be aware of innovations and to check whether present regulations can cover all the aspects of innovation. I believe that it's also for a regulator important indeed to have these interactions to be prepared and also to learn more about those things. The picture at the bottom is an innovation model, a stage gate model, which highlights some of the stages in the development of a process. And if you get into more detail about the safe innovation approach, you will need to make sure at which point you have to make which kind of decisions and interact with which kind of other actors. But unfortunately, time is too short now to get into that. So if you look now, this is in one picture where you have the safe innovations approach with the two aspects. And here is the interaction. And you can see that, well, it has to be along the different development stages. What's important to point out, I think, is, like I said, interaction between innovators and regulators is crucial. This can be in an individual product. So at an early stage, obviously, innovators wouldn't like to be transparent about what they're planning to do if they don't have a safe and trusted environment. So that's what's necessary in those kind of cases, which is done for, in many cases, already most well known in scientific advice for medicinal products, I think both in Europe and in the States and in other regulatory environments. but also open, transparent discussions during conferences or doing project meetings. Those are also important to achieve this game. So what are the advantages of all this beautiful approach? I think in the end you should have safer products on the market. The whole innovation process should be more efficient. It's the time to market should be reduced. And indeed, along the way, you have this knowledge exchange, knowledge sharing during your process, which I think is a benefit to everything. In this session, in my first talk, apart from explaining the safe innovation approach, I will focus more only on the medical devices. And in the next talk, Catherine Tyner will talk about medicinal products, so there's no need that I will talk about them as well. After that, Christina Giannakou is going to talk about a specific area of medicinal products, the immunotox evaluation. Then Ana Benito will have the Innovators perspective, and Mira Marcus-Kalish will talk about reliable, replicable knowledge and data analysis. So, medical devices, there have actually been important regulatory changes recently. The legislation of devices has always required careful risk assessment on a case-by-case basis. But currently, there are new regulations, and in contrast to the old directives, the new regulations have specific provisions for nanomaterials in medical devices. What has stayed is the fact that harmonized European or international ISO standards can be used to prove compliance with certain regulatory requirements. There again, those standards is an example of joint work by innovators, regulators, and preferably also other stakeholders. On the screen, I don't know if you can read it, these are some of the provisions in the new regulations. First one is the definition of a nanomaterial, which is basically the same one as has been recommended by the European Commission in 2011. The second one is general safety and performance requirements, where special attention shall be given to the safety evaluation of nanomaterials. So that's really a specific regulatory requirement now. If you look risk assessment of nanomaterials in devices, what are the principles? First of all, the basis is the same as for any other medical device, and specific characteristics of nanomaterials to be taken into account are the detailed physical-chemical characterization, the toxicokinetic studies in case there is potential release of nanomaterials, and you should be aware of any pitfalls in toxicity testing, for example, the sampling, interference, and mechanisms. The standard series for biological evaluation of medical devices is a framework, and it's based on the type of device, type of contact, the contact time, and depending on these, various biological types of testing endpoints are given up for consideration. Recently, last year, a guidance document was published specifically to help people guide how they should be doing these specific issues related to nanomaterials. One important conclusion is that a nano-related risk is primarily related to the release of nanomaterials. And you should also include in your risk assessment the generation of nanomaterials by wear particles. So this slide, in view of the time, I think I will not go over all of them in detail, but this is the type of information you will find in this guidance document, the ISO 10993-22. It will explain what kind of interferences you should be aware of, what kind of chemical interaction could occur, or what kind of other test properties might be such that they're simply not compatible with nanomaterials. So if you are working on a medical device using nanomaterials, I think this is a very useful guidance document. Very important change is also the classification rules. For those of you who are not aware, nanomaterial or medical devices, the process to get access to market is related to the risk class. And if you're in the highest risk class, then the largest amount of scrutiny has to be performed. You have to go to a notified body, and the process is just longer and more complex. And if you're in the lower risk class, then you have less administrative burden, there's less scrutiny. So this rule that has been contested says that they're in class 3, which is the highest risk class, if there is a high or medium potential for internal exposure. And so the other lower classes, if there is a low or a negligible potential for internal exposure. So this all sounds very logical, but then the question arises, okay, so what is high? What is medium potential for internal exposure? So when are we in class 3 or when are we in class 2A? In the recitals of the regulation, there was a mentioning to relevant scientific opinions, and there is a clue as to how this could be organized. I was involved in the negotiations in the final stages, so this has been a highly political issue in the final political negotiations on these regulations. But if you look in this scientific opinion from the Skinner Committee, you will find a table where also an estimation has been given of potential external and internal exposure as a starting point for a risk evaluation of medical devices containing nanomaterials. And I picked one part of it, which is the implant devices. The table is bigger, and you see that there's also a change, different exposure times. But most important, I think, is the device actually a free nanomaterial? Is it a loosely attached coating or a very much in fixed coating? Or is perhaps the nanomaterial embedded in a matrix? And then there's a difference if the matrix is degradable or if the matrix is actually also non-degradable. And then the Skinner Committee has made estimates of when there will be HL, that means high potential contact, and or external exposure, and low potential for internal systemic exposure. So the first is the external and the second one is the internal exposure. And here I think we have a starting point for doing this interpretation of Rule 19. The regulations have a lot of new things, and there is a roadmap that has been developed for implementation topics. And one of the topics there is to develop guidance on classification rules. And the lead for Rule 19 is a working group that I'm chairing. It's a New and Emerging Technologies working group. And here again in this working group, yes, innovators and regulators are working together. I hope to get that work going and moving at the last part of this year. So thank you for your attention. Yeah, and perhaps I should explain. In the program it says that we will have 25 minutes plenary discussion at the end. I prefer to have small discussions after each speaker. So that's how I would like to do it. Everyone who has a question, please talk into the microphone, because sessions are recorded, and if you do not talk into the microphone, you will not be recorded.
Robert,
Donald.
Thank you. I used to be a nuclear regulator a long time ago in my another life, and there you had to calculate what was the effect on the actual tissue, not just the exposure. So it seemed to me that you were just describing their exposure only. Surely there has to be some degree of what is the effect going to be on where it lands up. And also, presumably, this is a question of where they are landing where you didn't actually mean them to, because obviously they're having a profound effect if you're actually using them for a medical purpose. So is this just relating to nanoparticles where you did not intend them, or does it include in the actual area of intention?
Well, thank you, Donald. Perhaps that was not completely clear. This is in relation to the important conclusion that I mentioned, but it was on a full slide. That in fact, in the same Skinner opinion, it was stated that the highest risk related to nanomaterials in medical devices would be if there is exposure to free nanomaterials. So either the device is a free nanomaterial or there is a release of nanomaterials from the product. So then the exposure is the key to saying which types of devices you might have to put in a higher or lower risk category. That was the reasoning why and this is purely the risk classification for which kind of conformity assessment route needs to be followed. The actual risk assessment of a device still needs to take place on a case-by-case basis, and that'll take into account the other issues you mentioned. Thank you. Okay, I think in view of the time, we have this last question, and then we should move on. Dan?
Okay, well, the question is the following. I'm coming from the pharmaceutical area, and the device area always have been very sort of vague. Some other land where we don't know the rules, and we feel very unfamiliar with that. And nowadays, the device land, the device country is coming closer and closer to the pharmaceutical area, or the other way around, whatever. So we have, as a pharmaceutical scientist, I need to know the rules there. And I'm very pleased to hear that there is all kind of activities there. There are two questions here. The first question is, if you do this and you upgrade your rules, do you keep an eye on what the rest of the world is doing, in particular the FDA? And the second question is, and that's a little bit provocative, so you don't have to answer that, but you were talking about Europe. Do you include Britain or do you exclude Britain? You don't have to answer the second one, but the first one I'm very curious to see whether there is a sort of a tuning of the rules between the two, say, major, if I may say so, blocks there.
Yeah. Well, I'll start with the second question then. And I'm not a politician, and I'm not going to give any political answers, or at least not really politics. But what I can say is that the development of these new regulations has started in, well, actually maybe the first in 2008, and then in 2012 there were the first versions of these documents. So at that time there was no knowledge of any Brexit, and the UK has had a very important role in the development and negotiations on these new regulations. With regard to your first question, yes, I agree that there is an increasing convergence of medical devices and pharmaceutical products, which also means that sometimes for a borderline or a combination product, you will need to look at both types of regulations. At the same time, also there's a globalization. For medicinal products, there is the ICH. For medical devices, there is a forum which is called the IMDRF, the International Medical Device Regulators Forum, which have discussions together on how regulatory systems can be harmonized. It's on a relatively non-formal basis, so in the actual negotiations they are not included. But of course there is a discussion with all people from other parts of the world on the regulatory framework, and this is taken along, obviously.
But you know that the ICH is also the industry involved.
Yeah,
and
well,
so other parties, and that is apparently, what I understand, is not on the device side, maybe
not anymore.
Yet.
It used to be a different
it
forum.
Used to be, okay.
Yeah. But perhaps we can discuss in the break